First of all, I'd like to thank the organizers for giving me the opportunity to talk here. Moreover, I am grateful for your support. 감사합니다. Okay. Anyway, this is my this is the title of my talk, and this is the contents of my talk. First, I will talk about toric manifolds over cube, and second, I will talk about toric manifolds over one vertex cut of cube, and third, I will talk about our main. The most important thing. This is joint work with Sho Hasui and Mikiya Masuda and Sanjan Park. Sorry. And third, I will talk about main result, and finally, I will talk about toric manifold over one vertex cut over n-dimensional cube. Okay, let's start. Okay, as almost all people know, toric manifolds over cube is manifold over cube is the three-stage bottom manifold. Bottom manifold is iterated CP1 bundle. And it is known that the cube. I attach the label. Attach the label. This is minus 2. This minus 1, minus 3, and 1, 2, 3. I attach the labels to each facet, and let EI is the standard basis of Gn. Let EI is the facet. Let EI be the facet vector corresponding to F minus I. And let AI be the facet vector corresponding to Fi. It is known that three-stage bottom manifold determined by this part, I denoted matrix A, and it is the matrix A is of the form up to conjugate by permutation matrix. And it is well known that diffeomorphism classification of three-stage bottom manifold and yeah, let phi is graded ring isomorphism between let phi be a graded ring isomorphism between B3 and B3 prime. Then we know phi preserve Pontellian classes, and by the general result of Wall and Jap, we know then isomorphism. Then B3 and B3 prime is diffeomorphic. Yeah, thank you. Yeah. Okay. And second, I'm going to talk about toric manifolds over one vertex cut of cube. Important thing is determinant of A is 1 in this case, and one vertex cut. Let's cut this vertex, and I attach the label to new face. New face. Yeah, and and then we know the matrix A is matrix A. Sorry, I forgot. Let B, B1, B2, B2, B1, B3 is a facet vector corresponding to new face, a new facet. And non-singular condition for these vertices, we can find what the form is this part, and moreover if determinant of A is equal to 1, then this matrix is of the form And this, the toric manifold corresponding to this matrix is nothing but a blow up of, at a point of three-stage bottom manifold. And if determinant A is not equal to 1, then we can classify this matrix as follows. If determinant A is 0, then the matrix is of the form 1, 1, 1, minus 1, minus 1, minus 1. The toric manifold corresponding to this matrix is projective toric manifold. So, projective toric.
And there are three cells and the replicated.
So sorry.
So you, where is the channel? Could you show it?
This.
No.
This.
The matrix.
Ah, so
They are all zero. Yeah.
all zero, yes. All zero, yes. Thank you. And if the determinant A is equal to then the matrix of the form 1, 1, 1, 1, 1, 0, 0, 1, 1, 1. The toric manifold corresponding to this matrix is order threefold. This manifold is non-projective. And another and this form or this form. The corresponding manifold, toric manifold, is projective. And otherwise, the matrix is of the form 1, 1, 1, 1. Minus 1, minus 1, 1, 0, 0. Where A is not equal to 0, 1, minus 1. Actually, if A is equal to 0, then this type, and A is equal to 1, this type, and no, sorry, this type, no, the okay, calm down, yeah, one, and sorry, This type. Thank you. This type. And last one is 0. Okay, thank you. And the toric manifold corresponding to this matrix is projective. Okay. Any questions so far?
So, what sort of things did you do to show that this is projective?
Yeah, actually, I check by using computer program in Maple because three-dimensionally it works, but I have no idea to check the projectivity in general case. I think.
Checking projectivity is not so difficult.
But maybe as Hanjiro said, yeah, thank you. Yeah. Okay. Okay. 3.
Are they all possible? They are all possible.
They are all possible. Sorry.
These are the all possible characteristic functions.
Yes. Yeah. Yes. And our main result park is Sanjam Park. Yes. And, sorry. These type not diffeomorphic each other. Actually, these type are not these cohomology ring is not isomorphic each other, and by using the result of war and anyway, these cohomology ring is not isomorphic. Yes.
They are different by cohomology. They are cohomology. All these cohomologies are different.
Yes.
And what?
Each type. Sorry. Actually, we don't know in type 2. Sorry. 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 Could you say again?
Their cohomology rings are different, and their contracting classes are different, or how did you use the 6-dimensional classification?
How did you get it?
Yeah.
But his first statement, these types are different, not diffeomorphic, means if the types are different, their cohomology rings are different. That's his first statement.
Sorry. Yes. Yes. Thank you. Yes. Yes. Sorry, this is the second. Second, yeah. And in each type, type 1, the following statement is equivalent. The blow up of at a point of three-stage bottom manifold, two, three-stage bottom manifolds. Oh my god. If and only if these two three-stage bottom manifolds are diffeomorphic. As I said, it is known that diffeomorphism classification of this, so we can classify. And type 0, sorry, I forgot the remark. Okay. Yeah. Okay. Anyway, there is only one diffeotype in type 0. And the remark, type 0 in type 0 I denote MB and B is this B and MB prime as varieties if and only if these sets is equal B1, B2, B3, B1 prime, B2 prime, B3 prime as a set. So classification as variety is infinitely many numbers. Variety classification. That's a difference classification of diffeomorphism.
As a variety?
Yeah, as variety, yes, as variety. Yes, as variety, yes, thank you.
Diffeomorphism type is independent of...
Yes, independent of, thank you. Good, very, very important point. This is independent of choice of B. And in type 3 is otherwise case, is I denote MA, A is this A. MA is diffeomorphic to MA prime if and only if A is equal to A prime. And as I said, we are studying now. We study.
But type 2 has only one element, right?
Yeah, two. Sorry, 2 times.
You
Yeah.
don't know whether they are different or not.
Sorry.
So these two guys have the same cohomology rings?
Even though we don't know. Yeah, very difficult.
The cohomology rings are same or different?
We don't know.
Even
even the cohomology.
tell the difference.
Yes.
We don't know whether the cohomology rings are isomorphic. We don't know.
At least me.
The coefficient they are same. Because character function is the mode to
Only the plus minus.
I'm sorry. No. 1, 0, 0.
One
The
zero.
coefficient, I think they are the same. You check it. No?
You can check start with the G2 or 2 coefficient, then from what basis? What basis? Actually, with the field of coefficient, really, can be checked.
Here, for all the types, is there only one topological type, right?
Type 3.
The here differential type. I mean, the topological type.
No,
Even the cohomology rings are different or not. It's still the question. So whether this is homotopy equivalent or different. I mean,
I think only one take it the same.
It's the same.
Okay. And finally, okay.
main idea of compare cohomology rings, you should find some invariant.
Yes, actually, actually we use the property of cohomology ring. First, we consider the rank of this no. Sorry. We consider the square vanishing pair and annihilator, and we compare with rank of this set, and or some and some calculation. Sorry. And okay, finally, I'm going to talk about Toric manifold over one vertex cut of n-dimensional cube. Key lemma Masuda and Panoff. Let A be n by n integer matrix suppose every principal minor of A equal 1, then A is the following form. A is of the form if determinant A is equal to 1, and otherwise A is this form. And in our case, this assumption, is, in our case, it is satisfied this assumption. It corresponds to non-singularity condition for every vertex except for the face, new face. Except for vertices contained in new face. So yeah. Yeah, this statement means actually non-singularity condition is this part. So our setting it is whole. And then okay. And then we can classify the matrix AB is the following type. One determinant. One is this A1. A21 B is equal I. And if determinant equals 0, B I equals 1. And determinant, if determinant is 2, and where B equal AI, and AI is -1 or 1, and number of AI equal 1 is odd number. So we assume A1 to AN are -1, -1, 1. This is odd. Up to conjugate by permutation matrix. And otherwise is 1, 1, -1, B. Sorry. We forgot. I forgot B. Where A is not equal 0 plus -1, and B is equal determinant A over 1 summation of N AI. And okay, B 100 10. Thank you.
When you say determinant, that's determinant of A?
Sorry. Yeah, we generalize three-dimensional case. So we A and B.
So the A is when you say determinant, that's determinant of
Sorry. Sorry. Determinant. Sorry.
In zero case, is determinant of 0 here?
Yes.
What number? What it depends on N?
Zero.
Yeah, if N is -1, -1, -1 to -1 to the nth power, and it depends on R or A.
Yes. Yeah. This is independent of N. Although even.
Okay, go ahead.
Yeah, actually, first we some the each and
Okay.
yeah.
Plus 3 actually.
Yeah.
What is B?
Okay.
When B should be removed. The type circle. Yeah.
What else?
Yeah.
Then means A is 0? No. I mean, you should remove that.
Remove the
Remove. Yeah.
B.
Yeah.
That's
B
the one.
equal.
Sorry. Yes. Yes. And fine. Just please one more. Okay. Thank you. Finally. Actually. Sorry. Actually, we see the cohomology rings of this type are not isomorphic. Each type, and as Sege argument of dimension is equal to 3. But we do not diffeomorphism classification because in type 1 we know bot manifold we can prove these two manifolds are diffeomorphic if and only if cohomology. Sorry, the level of cohomology. I confused. Sorry, I thought at least we can prove the cohomology ring of cohomology ring and but we do not diffeomorphism classification, and in type 3 we can we know classification of diffeomorphism classification because yes. Sorry. So we know that this equivalence, and in type 0 cohomology ring cohomology type is independent of choice of B.
So there's only one?
Yes, cohomology ring, yes. And in type 2 is very difficult. Yes. I have no idea. Yeah, okay, thank you. Thank you.